All right, today we're going to continue probability. We're going to do simple probability and its complement. So remember, probability is a ratio between the number of desired outcomes to the total possible outcomes. And then here's our ratio written here to determine probability. So let's look at our first simple probability. What is the probability of rolling an odd number on a fair-sided die? So a die is 6 sides, numbered 1, 2, 3, 4, 5, 6. So we're looking for the probability of an odd number. So we have 1, 2, 3 odd numbers. So that's the number of favorable outcomes, 3, and the total number of outcomes is 6. And then for probability, we want to simplify our fractions. So the probability of rolling an odd number is 1/2. All right, so what is a complement of an event? It is the probability of a non-occurrence of a desired outcome. It's what you don't want. So here's an example. What is the probability of not rolling an odd number on a fair-sided die? So the complement can be addressed by determining the probability of an event and then subtracting the probability from 1. So 1 minus, and the probability of getting an odd number was 1/2. 1 minus 1/2 equals 1/2. This is the probability of not rolling a 1. So the outcomes of a simple event and its complement completes the sample space. So not odd, right? And not odd numbers are even, which is 2, 4, and 6. And you can see the odd. So it's complement 2, 4, and 6, and its complement, they complete the sample space, which gives you 1 whole. Okay, so this relationship here is the probability of the simple event plus the probability of the complement is going to equal 1 whole. And remember, probability is between 0 and 1. So that gives you 1, 100%. All right, let's look at some examples. Complementary events are 2 events in which either one or the other must happen, but they cannot happen at the same time. So for example, a coin can either land on heads, which is 1/2. There's 1 head out of 2 outcomes on a coin, or not land on heads. And that probability, again, not heads is tails, right? And there's 1 tail out of 1/2. If you take the probability of each event above, the sum of their probabilities will equal 1 or 100%. 1/2 plus 1/2 equals 1. So I'm gonna, how about you try number 1, 2, and 3, and then we'll check. So you're more than welcome to pause the video and then press play to check your work. What is the complement of rolling a prime number on a die? So the die's outcome is 1, 2, 3, 4, 5, 6 outcome, and the prime numbers are 2, 3, and 5, right? So we want the complement of that. So 1, 4, and 6 are not prime. So that's 3 numbers out of 6, which simplifies down to 1/2. Number 2, there's a 90% chance it will rain. What is the probability it will not rain? So 100% minus 90% equals 10%. Number 3, a fair die is tossed. What is the probability that it does not land on 4? So not land on 4. So the probability of a die landing on 4, there's only 1 4 out of 6. And again, we're going to out of 1 minus 1/6. Okay, so I see 1 minus 1/6, so this could work. We're not going to add. It's not 1/4. The probability of getting a 4 is not 1/4. And again, we're not going to add. Since the probability that the die lands on 4 is 1/6, which we determined here, the probability that it does not land on 4 is 1 minus 1/6. All right, I want you to go ahead and try these 6 problems. Okay, you can go ahead and pause your video, work these 6 problems, and then you can press play to check your answers. The table shows the types of movies and the numbers of DVDs rented by customers at a store in one day. Based on the data in the table, what is the probability that a random customer will rent drama? So here's drama. So we have 25. And then we need to add the total. And that gives us 125. So 25 out of 125 customers rented drama. And we always want to simplify our fraction. And that simplifies down to 1/5. Okay, another simple event problem. The spinner shown is divided into congruent sections that are labeled 1 through 7. If the spinner is spun 1 time, what is the probability of the arrow landing on a section greater than 4? So numbers greater than 4 are 5, 6, and 7. So there are 3 possible outcomes, and out of the total, there are 7 sections. And our fraction is simplified, and that will be our final answer. Let's look at problems that are complement probability. Based on the data in the table above, what is the probability that a random customer will not rent a drama? Okay, so we know it's going to be 1 minus 25 over 1/25. And actually, we simplify that to 1/5. So let's go ahead and use that. Minus 1/5, and that gives you 4/5. All right. This next one, if the spinner above is spun 1 time, what is the probability of the arrow not landing on a section greater than 4? So we're going to take 1 minus, and we found the probability of numbers greater than 4, which was 3/7. So 1 minus 3/7 is 4/7. All right, let's look at some prediction problems with simple probability. A friend of Anne did a random survey of the students in the school and found that 65 out of 100 students plan to vote for Anne for student council, which is the best estimate of the total number of votes Anne will receive if all 1,500 students of her school vote. So 65 out of 100 total students. So our new total is out of 1,500. Okay, we see a relationship here that we can multiply by 15. So we're going to multiply by 15 at the top, and that gives us 975. So the best estimate of the total number of votes Anne will receive out of 1,500 is 975 votes for Anne. All right, one more. Samantha's playing a game with the spinner shown below. If she spins the spinner 24 times, so that's going to be the total, how many times is the spinner likely to not land on 1? So I can see this is not 1. Okay, so there are 1, 2, 3, 4 that are not 1 out of 6 total sections. Okay, and so I see a relationship here that we can multiply by 4. So we're going to multiply the top by 4. 4 times 4 is, I'm sorry. Yeah, 6 times 4 is 24. So 4 times 4 is 16. So that would be 16 times.